is Mohammed Bashir from ATS, Specification Account Manager covering the Ontario market. Joining us today is Owen Dwyer from SMS, and we'll be presenting corrosive waste, acid corrosive waste. And as I mentioned, this presentation will be recorded so that we can send the recording after the presentation. Also, for anyone in Canada, we'll be sending out certificate of attendance as well. With that being said, the floor is all yours, Owen.
Great. Thanks, Mo, and welcome everyone. I appreciate the opportunity to get into your eyes and ears this afternoon. I may have met some of you. Some of you may have seen this presentation before. I've been in the industry for 26 years. Been with SMS as their national sales manager for about 10 years, and prior to that, I was a technical sales rep for IPEX for Ontario and Northern Ontario, and then in the U.S. Market for IPEX as well. And my education is in the sciences, in biology research, and I sell pipe. Go figure. Anyhow, welcome everyone. I appreciate your time. Today's topic, we're going to be going over corrosive waste and neutralization systems and how that pertains to the code. So just a quick agenda. We finished the intro. I'm going to talk mostly about national codes here in Canada. Interprovincially, for the most part, they're verbatim. There's not many, as far as the topic we're going to talk today. I'm going to go fairly quickly through some of it, but I do want to touch on some important points so you do take away something from this presentation that you can use in your daily lives. And here's the intro. We're going to go through codes, different types of systems, unit value comparisons, typical applications, material selection, etc. Just one quick question, Mo. Are you going to be monitoring a chat? Is there a chat today?
Yes, so I was just going to mention that if anybody has any questions, you can type in your questions, and I'll interject and to get the questions answered.
Great, thanks, Mo. So just to jump right in, what does the code say with respect to corrosive waste in our national code? Essentially, on the left-hand side is the blown-up version. In our 2281 in Ontario, it's 7281. But essentially, it says pipes and fittings that are going to be used for the drainage and venting of corrosive waste shall conform to, and shall in our code means must. So A is the silicon iron castings. So that's a material. B is ASTM C1053 borosilicate glass, and C are your CAN CSA 181.3 plastics. So your polyolefins, your PVDF material. And full stop. Those are the only permissible options if you are doing a DWV system here in Canada that has corrosive or acid wastes. And again, A, B, or C. And I'll reference A, B, and C in future slides. Venting. It also goes and elaborates into venting in 2553. Venting for drainage or dilution tanks that are conveying corrosive waste shall extend independently and terminate in outside air. See Article 2577, I'll get to in a moment. But this section points to the separation of corrosive waste from your sanitary system. At one point, you used to be able to tie your corrosive waste vent into your sanitary, but what they found is that your corrosive vent would just condense again into liquid form once it was inside the stack, and it led to further corrosion. So at this point, if you are venting corrosive waste or your dilution or neutralization system, they terminate in outside air. 2577. So venting for sewage pumps, dilution tanks and neutralization tanks are used interchangeably within the code. They are considered to be the same thing. I'm going to go through why they shouldn't be considered the same thing, but for the purposes of discussion, if you see dilution tanks in the code, it's referencing neutralization as well. So second point is the most important. The size of every vent pipe in a sewage pump or dilution tank, it shall be not less than 2 and does not need to be greater than 4. So there is no 1.5-inch venting. You do have to vent a neutralization or dilution tank and vent sizing is stipulated there. So again, referencing back to those ABC, those types of pipe that were selected or referenced at the beginning of 2281. Duriron. Duriron is a product that you may know if you've been in the industry long enough, where you've come across it in the older master specs. Flowserve was a corporation that produced this material. They were somewhere in the northeastern US, and it was a no-hub style connection system, and it kind of looked like cast iron, but what it did have was an additional silica sand in its recipe, giving it the ability to withstand more chemicals. So unfortunately, or fortunately, in April of 2016, it was discontinued. It was the inception product over 100 years ago. Again, with that additional silica sand in that recipe, gave it the ability to withstand corrosion. It's no longer available, but as you can imagine, like a dinosaur bone, every once in a while they get dug up on an old job site, and now we can't add to the Duriron system. We now have to adapt to those. So using transition couplings such as Mission FKM or Dallas specialty couplings, we can do those transitions and still be code compliant. So B of that A, B, and C is borosilicate glass. It's under the non-combustible piping umbrella, so similar to copper, cast iron, any of your metals in a building. So it comes with its set of fire stopping traditions and whatnot. But the acid waste borosilicate glass is, most people don't know, made by skilled tradespeople. So unlike cast iron that comes out of a casting, or plastics that come out of a mold, every single glass fitting is made by a skilled tradesperson. So they'll take a small section of glass pipe using heat by a torch and jigs. They will bend 90s, 45s, and using carbon rod, they will make the shapes required for a standard plumbing system, be it a TY or a 45-degree elbow, et cetera, et cetera. So in that comes some cost, and we'll talk about unit value comparisons later on. The way glass is joined, it's joined with a stainless steel kind of jacketed fitting with the white part that you see in those two fittings is Teflon. And if you can see from the next slide, there's a bead to bead coupling and a bead to plain end style coupling. So what does that mean? All the pipe ends are beaded, or the fittings are beaded, and that's where you would use a bead to bead coupling. And for example, if you're cutting a piece of pipe, they come in 10-foot and 5-foot lengths. So obviously a field cut of a 5-foot or 10-foot length, you're going to have a plain end now. So the bead to plain coupling is what you would use in that scenario. Because glass and other materials used that I'm going to talk about shortly, polypropylene and PVDF, are made to iron pipe size, they too can be, this bead to plain coupling can be used as a transition fitting. So we've covered the A of that 2281 of A, B, and C. B is the borosilicate glass. A is the Duriron product that is no longer available. And just to note, if you do look through your master spec and you do have Duriron listed, take it out, doesn't exist anymore. You're going to create some problems for yourself. So what's left is borosilicate glass and the CSA 181.3 polyolefins that fall under that C bullet point, if you will. So plastics, those plastics for corrosive waste, back in the mid 1990s, plastics were introduced into this corrosive waste. And as we know, plastics are considered combustible. And some special provisions had to be made to accept or to allow polypropylene in combustible applications. And those are pointed out in this next slide. 31516, this is specific reference to the OBC, but it's also in the national codes as well. So 3.3 here that's highlighted, polypropylene pipes and fittings are permitted to be used for drain, waste, and vent for the conveyance of corrosive waste, and to distribute distilled or dialyzed water in a laboratory or hospital, provided that, here's the provision, that the building is sprinklered. So if you're doing an older building that is a retrofit and it does not have any sprinklers in the building, polypropylene is not a permissible product for a corrosive waste application under that scenario. And again, because polypropylene is combustible, it's not permitted in a vertical shaft. And you can see the C point that's not highlighted there is any penetration. You have to have your regular fire stop devices that are abundant these days, Hilti, 3M, Trimco, all of those folks, as long as it's compliant to the CAN ULCS 115 fire stop standard. So there's various plastics, various plastic manufacturers, different bells and whistles, how they go together. Unlike glass, you have a bead to plane or a bead to bead. In the plastics, you range from different materials like polypropylene or PVDF. I'll touch on PVDF shortly, but you have different manufacturers with different joining methodologies. One thing to note in your spec is just to say must comply with CSA 181.3. That's kind of the catch-all for all parties in play. And I'll just go through real quick on the systems. So polypropylene, you're typically talking about a flame retardant polypropylene. For just drop some trade names, IPEX trade name for that would be either Enfield or Labline, regardless of their joining method. You would have a Watts system, which would be either blue line, their non-flame retardant would be brown line. So be careful of using those trade names in your specifications, again, because you're going to knock out other viable products. Again, I reference that 2281 standard that spells out CSA B181.3. And finally, PVDF. So PVDF is a thermoplastic as well that carries properties similar to, if you're familiar with PVC XFR from IPEX, for example, it meets flame and smoke. So if you do have an application where you did have a flame and smoke requirement, going back to the analogy that I used of a building without sprinklers, if you wanted a plastics option, PVDF would be the only requirement left on the plastics option for corrosive waste or glass. So in most systems, you have either a fusion or a mechanical joint. Fusion is predominantly what's used for below grade applications. Mechanical joint is typically for your below the bench kind of accessible areas for obvious reasons, but it's recommended to go with fusion for the maximum extent possible. And again, I just wanted to point out that we're only talking drainage here. This is not for the conveyance of chemicals in a pressure application. Most manufacturers list their products available from 1.5 through 12. Some manufacturers list up to 16, but again, not very common, and that's likely a fairly long lead time coming from Europe, likely. Unit value comparison. So a unit value comparison, if glass was our control factor with a unit value of 1, that PVDF product would have a unit value of about 0.75 and polypropylene of 0.35. So that said, in your specifications, you should try to look towards polypropylene as the viable option for the situation, taking into consideration chemicals, temperatures, sprinklered buildings, plenums, etc., just based on cost value alone, and then work from there. And you can see why the Duriron went the way of the dodo bird over the years. It's 3.5 that of the glass, or 10 times more than the available polypropylene plastics options today. So again, just for quick math, if you've got $1 million of pipe and fittings in a glass project, that's a $350,000 comparable takeoff in polypropylene. So as far as ticking those boxes, you're trying to produce a viable solution for a client. Polypropylene should be the first product that you consider. Also taking into consideration then plenums. Plenums would be PVDF and glass, not polypropylene. Sprinkler buildings would not permit polypropylene. Unsprinklered buildings would not permit polypropylene. So then again, you're left with PVDF and glass as your only two viable options. So, corrosive waste. It talks about all of the A, B's, and C's that we went through. But in 2281, as a general catch-all in our code, it talks about materials and equipment shall be suitable for the purpose, which makes sense. So at no point do you put glass connecting to a PVDF product and then use a standard kind of Fernco coupling, like a standard rubber jacketed coupling in these applications. Everything has to be used suitable for the purpose, as per 2211, second point there. The proper transitions are similar to what I mentioned before, like a mission style coupling, a Dallas specialty coupling. There's specialized rubbers that are used in high temperature and chemical applications. Make sure it's suitable for the application. And just in general, there's other accessories available like tailpiece adapters, cup sinks, bottle traps, etc. So staying on the general accessories, you have smaller tanks, you have larger systems. Neutralization systems are a requirement, solids interceptors, and pH monitoring. So the next part of the presentation is going to go into the neutralization part. So as a kind of a shock, there's not much to say in our code with neutralization. So that's kind of the meat and potatoes of this presentation that I'd like you to take away with you today. Where do you find these corrosive waste applications? Typically high school laboratories, hospitals, research type university facilities, industrial pharmaceutical applications, and food and beverage. Anywhere where you've got a excessively corrosive DWV system that's connected to sanitary, these are the applications. So why do you need to use it? Because it's a requirement, a shall conform to A, B, and C. These are your three options: polypropylene, PVDF, or glass. You have a complete product line where it's combustible, non-combustible, plenum, shafts, etc. Chemical resistance, all of that needs to be taken into consideration. And again, reiterating the 2281, shall conform to A, B, and C. You can't use stainless. You can't use CPVC. You can't use PVC. You can't use, whatever other material that somebody is proposing that you should consider. Our code is pretty black and white when it comes to DWV applications for corrosive waste. So the neutralization part of the presentation, how am I doing for time? Good. Neutralization part of the presentation is quite important, and I'd like to again spend a little bit more time there. That's kind of why I'm not necessarily rushing through, but as a quick review on the piping, it's very specific when it comes to requirements for corrosive waste. 2281 are your A, B, and C pipe requirements. 31516 talked about the combustible pipe restrictions and the provisions made for polypropylene in a sprinklered building. 3643 talks about plenum requirements, that's the flame and smoke. Venting. 2553 talks about venting independently into open air. You don't tie into sanitary. Vent size requirements we talked about. Shall not be less than 2, need not be greater than 4 in general, as well as for your connections to your neutralization dilution tanks. Any plumbing system also takes into consideration vertical shafts, fire stopping, slope, etc. So in the grand scheme of things, all of that is standard fare for a corrosive waste system. You just have to make sure that you're selecting the right material of those three: polypropylene, PVDF, or glass for the application. Again, plenums, shafts, chemicals, temperature, etc. So as I mentioned, when it comes to neutralization in the code, this is what we're given. So in 2444, where a fixture or equipment discharges corrosive waste, corrosive or an acid waste, it shall, again in the code, shall means must, discharge into a neutralization or dilution tank that's connected to the sanitary drainage through a trap or an indirect connection. 2 is the part that I've always banged my head on the wall, is neutralization and dilution tanks shall have a method for neutralizing the liquid, period. So it doesn't give you anything, doesn't give you references to anything. The important point to take away is there is no standard. There is no CSA standard or anything like that that these manufacturers of these neutralization or dilution tanks have to conform to. So what does that mean for all of us? These are engineered and engineered design systems. So it's up to us in the industry to make sure that these tanks are designed for the application at hand. So let's kind of pull back a little bit. What is corrosive waste? So it's set by sewer use bylaws. So every municipality has a set specific bylaw with respect to permissible discharge limits, be it temperature, solids, chemicals, and whatnot. Anything that's going to be harmful or detrimental to the aquatic environment, to persons and whatnot. These bylaws not only govern the level of pH as well, but they also are set to impose fines. So the way they do it typically is through sampling originally. So if they have a suspect facility, they do grab sampling where they'll take a sample from the catch basins outside the facility and test to see if the pH is within permissible parameters that the bylaw, the municipality sets. If not, they will then do, that gets flagged, and then they'll have a 24-hour sampling as well. And those fines are hefty. So if a facility is found to be out of compliance with municipal bylaws, those fines are quite substantial. Most municipalities also put in their sewer use bylaws that neutralization by way of dilution is not permissible. And that's for obvious reasons shortly. When I was in school, one of my profs said to us, the solution to pollution is dilution. And the meaning, what we had is we would dump our beakers of liquids, of chemicals down in the sink, and all we did was keep the cold water tap on for a couple minutes just to flush that through the system. So not only is that a NIMBYism approach to the issue, it's concerning, obviously, with any facility downstream. So you've got cast iron and whatnot that will definitely corrode quite quickly in that type of a scenario. So why neutralization should not be classified or considered as dilution? It's a waste of natural resources. It affects the downstream waste treatment facility with excessive volumes. If everybody did that, they just have this huge influx of volume that would almost kind of pre-push all of the effluent that they're treating out of their system. Most municipalities, it's non-compliant. They don't want you to use dilution as a method of neutralization. And again, you're not really doing anything. If you're using dilution by way of forcing water through the system, you're just flushing it out of your building and making it somebody else's problem. So I'm going to transport everyone back to grade 7 science class on this pH scale here. For those of you that have a pool or a spa or that have had recent dealings with pH strips, litmus paper strips, you'll recognize some of the scales here, but every level of pH change. So for example, from a 4 to a 5, it's referred to as what's called a decade unit. So every decade unit or change in those numbers is representative of a 10 times in concentration of either acidity or alkalinity. So looking at that scale, if we're talking in the grand scheme of things in neutralization, neutral, we're not trying to hit 7 for our neutralization process. We're trying to hit within the range of the sewer use bylaws permissible discharge limits. But let's say, for example, we're talking dilution here. So a pH of 6 is 10 times more acidic than a pH of 7. The difference between a pH of 5 is 100 times more acidic than a pH of 7. So if you carry on, if I had an example for a 1 liter of acid with a pH of 1, and I wanted to make that neutral, so a pH of 7, following those zeros, it would take 1 million liters of clean fresh water so that pH 7 exact would be achievable. And again, there's a lot, you do get dilution over time, so it's not perfect math per se, but just to give you a visual perspective of what that means. So 1 million liters of water, that's like 50,000 5-gallon jugs, or enough water for 15,000 showers. So it's not, the mindset should not be dilution. We're not trying to add water or flush it out of our system. We want to treat it. And in doing so, treat it on the site. So when it is discharged from the building, it's acceptable. It's within the sewer use bylaw parameters. That said, in our discussions and scenarios that we found where dilution is the answer, for some applications, is for dialysis waste. Dialysis waste is acidic. It ranges from a pH of 4.5 to 5.5. If it was just going directly into the system, would require treatment in large volumes. However, it's viscous. It's kind of like a consistency of like a latex, thick latex paint, and it would become detrimental to a limestone system. So if you have a gravity-fed system with calcium carbonate limestone, which we're going to talk about shortly, it would render that limestone system dead, useless, because it's now coated all of your limestone, or because of its viscosity would just kind of back up. It would back up your flow through a limestone system. So again, sometimes these dilution systems for dialysis are a push button control system through a flushing floor drain rim style, or a tank with injection ports. Again, for smaller controllable volumes. But again, dilution is not necessarily the answer for corrosive waste. And if you have a large facility that is predominantly dialysis, you should consider another option, which we'll talk about shortly, which is an injection or a chemical treatment type of system. Pardon me. So moving on to different types of neutralization, you have passive, which I mentioned, which was your gravity-fed neutralization system through calcium carbonate limestone. And you have the sizing is dependent on contact or dwell time. So you want to have that acid content in contact with that calcium carbonate limestone for a specific amount of time in order for that chemical processing to happen. Because calcium carbonate is limestone rock is calcium carbonate, and it in itself is in a solid form. It is in the range of a pH of 12 to 14 if you had to dilute that or make that or liquefy that calcium carbonate. So it only works for acids. So a calcium carbonate system is very specifically suitable for predominantly acidic effluent. You're not going to use a calcium carbonate limestone drainage system or neutralization system or caustic waste for something that's on the alkaline side. Where the alkaline neutralization comes into play is an active system. So an active system takes a neutralization, makes neutralization by way of chemical opposites, if you will. So if you have something that's alkaline or on the upper side, so on that pH scale on the 7 to 14 side, you're going to use an acid to get to neutrality. If you have it the opposite, if you have an acid effluent, you're going to use something that's alkaline to get towards that acceptable discharge limit. Gravity flow, again, passive. This is what a typical system would look like. I'll talk about interceptors shortly, but this is your main tank. You can see that it has to be vented. Downstream on the right-hand side, you can see cast iron there, because now we're deemed non-corrosive. Cast iron, PVC, whatever the standard sanitary pipe du jour is there, is acceptable. I don't know if you can see in the background there, there is a pH monitor in this system as well. How does the facility know that they are within sewer use bylaw compliance? Is typically a pH monitoring system, whether it's a standalone alarm, bells and whistles, or if it's integrated into the building management system. Typical laboratories would be predominantly acidic. So your school, university, hospital type applications are going to be predominantly acidic. Solids interceptors, as shown on the left hand side of that larger tank, specifying details. Again, going back to these are engineered design systems. The more information you put in your spec, the better it is for all parties because it gets rid of the ambiguity and again, putting in the detail circumvents substandard material being put in. So I'll talk about the interceptors shortly, but very quick overview on how to size a gravity-fed neutralization system using limestone, based on fixture unit counts, and we allow for a minimum of 1 gallon per hour per fixture unit in the system. So what does that mean? I have sinks, eye washes, floor drains, emergency showers, glass washers, all of that. So as per our National Code 2493, the hydraulic loads for fixtures kind of looks like this. Lab sinks would fall under other sinks, of which are 1.5 fixture units. So very quick example. You've got a small lab, 20 lab sinks, 1.5 fixture units per sink. Total fixture count, you add up. So if you're tying in your floor drains, your emergency equipment, your dishwasher, etc. So you're adding up all of your fixture units, adding your safety factor, 10 or 15%, and it gives you a number. So what is that number? That number is actually your functional capacity. What volume of liquid does my tank need to hold at under these parameters? So this calculation spits out a 62.7 to 65.5. So when selecting a tank, you want to have a functional capacity of 65 gallons. So there's a hole in my bucket. So I keep mentioning functional capacity. So take, for example, a Home Depot 5-gallon pail. If you drill a hole in one side for an inlet, drill a hole in the other side for an outlet, drill a hole for a vent, and then you fill it with rocks, why call it a 5-gallon bucket? That's an irrelevant volume. So in its unchanged form, it is capable of holding 5 gallons. However, for purposes of discussion and design for neutralization systems, it's best to design the system and reference its functional capacity. So that 5-gallon Home Depot analogy, that may only hold 2 gallons of water. So just take that into consideration when you're doing a comparison between one supplier, for example, and another. Make sure that it is a comparable volume, functional volume. So going back to our sample, a 65-gallon tank would be approximately 36 by 48 diameter. So empty, it's 142 gallons, but again, that's an irrelevant number. I want that tank to hold 65 gallons of liquid. That comes with a diameter approximately 36 by 48. Another detail to put in your spec. A typical system would look something like this. And what we recommend, if you're not going to specify a solids interceptor, and you can see why they're recommended, highly recommended, is because now you have a 36 by 48 inch tank, and that tank itself, if you look on the far right hand side, requires it doesn't say on this graph, I apologize, it's approximately, let's call it 1,800 or 1,500 pounds of calcium carbonate limestone. So if this dip tube were to become blocked with whatever the students or staff were putting down the drain, now you have a problem. You've got to get by 1,500 pounds of stone to access that small dip tube. So the interceptor prevents that, and at the very least, or in addition to, add a clean out on the top of your dip tube, so you can actually have the ability to service that in the event of a clog. Typical above grade system looks like this. Again, vented tank, interceptor on a stand. If you don't specify a stand, you'll get cinder blocks or suspended from the ceiling with threaded rod or milk cartons or whatever, specify, give the details there. You can see the image on the left, same thing, good Canadian jobs, got a Tim Hortons cup there, but you can see that this is a 3-tank system. So if you're doing a system that's in an existing building or the footprint you're given will not allow for a larger tank like the one on the left, you could just do a 2-tank system, take that volume required, split it over 2 tanks, and it gives you the same capacity, but split down into 2 different tanks. Flush with floor. So the same type of scenario with limestone you can do with a flush with floor assembly. And again, you have a functional capacity you're aiming for, depending on the thickness of your slab, the depth of bury. You have to maintain that liquid level as your outlet. That's your functional capacity. How does that come into play is your developed length. So if, for example, the architect or the building owner says, no, we don't want the neutralizer in this room anymore, can you please put it over in this section? So now you've got to take all your piping, you've got to maintain your slope. So now your tank, I'm going to go back one, your tank volume your tank inlet is no longer here as designed originally. It's now down here. Your outlet's lower. Again, how do you maintain that capacity? That capacity, what you would have to do is either change the diameter of the tank and the depth of the tank, et cetera, to accommodate.
Hi, Owen, there's a question here. It says
Yep.
one of the pictures shown display 2 tanks in series.
Mhm.
What would the tanks be in series versus parallel?
In series, in parallel, it's hard to direct the flow equally. So we would always recommend in a series application, the first tank is going to see more acid activity on the limestone. Second one, so just say for example, rough speaking, you have a pH of 4 coming in to the first tank. Its limestone is going to be reacting more aggressively towards the pH 4 coming in. Second tank may see pH 5, and that pH 5 again gets actively, so the first one might require a little bit more maintenance, but if it's in a parallel system, it's harder to control. Sometimes in a parallel system, it's not necessarily parallel, but it's a redundancy for maintenance purposes. I hope that answered the question. There's a little tip on the side here that I've put. If it is an existing building and you're adding a new neutralization system to accommodate an expansion, don't forget to consider the door openings when you're again going back to that 36 by 48. If you have 32-inch diameter, 32-inch, 34-inch doors, you're not getting a 40-inch diameter tank through those doors. So sometimes that's why it would lead you to a series system if you've got some restrictions like that. So whether it's the footprint or the doors, the accessibility throughout the facility. Injection neutralization is very straightforward as far as a schematic here. You've got dosing pumps with a caustic or an acid, or just one, depending on the system. You've got an agitator, pH controller, level sensors, all of that stuff. All of that can be connected to the BAS system, and then you have your treated effluent. Alkaline systems require this type of a system, again, because limestone does not have any effect on the pH going out. And the way we size these are based on estimated maximum flow through the system. As we did before in the gravity fed system, you would take your fixture units. In an injection system, you would take your maximum anticipated flow rate and add your retention time. So in your GPM, just say, for example, we like to use a 15 times multiplier. So if you have, let's go through an example, you have 10 GPM. I want to hold that 10 gallons coming into my tank for 15 minutes. My tank capacity has to be 150 gallons. When you 10 gallons per minute times the 15 for 15-minute retention time. You'll see systems such as this on the left-hand side, which is a skid mount, all the bells and whistles and alarms and whatnot. and systems on the right, which are individual components set within the facility as required. What they have are caustic and acid pumps mounted over a tank. On the left hand side, you can see there's like blue pumps mounted on those two tanks inside a spill tray, and then you've got the ones on the right, which are the black. Same scenario. I don't know. I saw another chat come up there, Mo.
That was a question just regarding the certificate of attendance, and
Okay,
I've
thanks.
already answered that question.
Okay, I'll leave that with you then. I'll ignore them as they come up. So an injection system will look typically, again, like these types of systems, whether it's a one tank or a two tank. Again, you can see on the right-hand side, we'd recommend, if it's an above grade system, which injection systems always are, you can recess them and put bollards around them kind of thing. But because of the agitation requirement and the dosing, they're above grade. Again, some more samples. They could be relatively small and straightforward, or they could be fairly large and complex. The level of scrutiny. So this is again going back to the importance of the design and the detail that you put in your design. They're installed for the life of the building, not just a few years. More detail in your specification to avoid substandard products on the job. An inspector sees this magic box. They know a neutralization system should be there because they've seen it in multiple projects, but they're just ticking a box. They don't know if it's the right size, if it's been designed properly, and they're just saying, okay, it's there. Thank you, Mr. Contractor.
Another
Again,
question, Owen.
yep.
Should the interceptor get additional seismic restraints on the little stand?
It depends on your region. We have not been involved with seismic restraints. West Coast, absolutely. I don't know what those would look like, if it's just a standard bolting to the ground, if there's any type of rubber footings. That's, again, the sourcing of the tank is one thing, and what type of, sorry, not the tank, the stand. It has to be obviously applicable for the application. I don't know much about what that stand would look like in a seismic application, but yeah, if it's a requirement for your region, it does have to be considered. Maybe suspending it from the ceiling is the way you go in that application. I hope I've addressed the concern or the question there. I'm not familiar with the seismic requirements, but I'm sure if there is one, you need to have that tank secured down. Normally speaking, it would be the addition of lag bolting on the actual interceptor and the neutralizer as well. So they would have fabricated feet put onto it, so they could be anchor bolting to concrete substrate. Going to go through relatively quickly here some of the options that you're going to see. The basic take home, when you're talking about a tank, most manufacturers purchase a rotationally molded tank from a tank manufacturer. They say, okay, I want a tank that's 36 by 48. The tank manufacturer does not know what the end application is. They're selling their tank. So it's a high density polyethylene tank. It can be non-pigmented, kind of translucent, kind of milky color like we saw in some of those previous examples, or black UV with UV inhibitors and carbon black for longer durability and whatnot. They don't know if you're using it for a neutralizer. The tank manufacturer sells the fabricator a tank. They don't know if you're collecting rainwater, storing dog food, or shipping bird seed. So that tank, as its natural form, has to be modified to suit the purpose. And normally speaking, that's the removal of that flange lid or that lip to make a proper flanged lid that you can bolt a stainless steel, using stainless steel bolts and a gasket and all of that stuff to make it suitable for purposes of a neutralization tank. So for example, taking a pipe wall, cutting it off, welding stainless steel, flange gaskets, O-rings, whatever is necessary to maintain or to you have acids, you're collecting acids and caustics from the whole facility into this one tank. You want to make sure that that tank is robust enough to withstand the rigors of its application. Below grade, you're going to have to beef it up a little bit. So the first cutaway was an above ground. This is a cutaway of a below grade. You're going to have to beef it up for foot traffic. Again, most applications are not vehicle. You would like to put these away and avoid vehicle traffic, but foot traffic for sure. And with that said, what are you doing with your stainless steel hardware? You're not ever going to access the bottom of that to hold the receiving nut and washer. So again, details in your drawings about receiving nuts. Some suppliers use what's called a hot sunk receiving nut method. And you can see from an image here that that receiving nut is welded and permanently fused into the bottom of that tank. Non-skid tops, obviously for foot traffic. And so again, this inset here is this, would you consider this an equal? So this image here shows you that the fabricator did not remove the standard factory kind of L-shaped lip of the tank that it came with. The other examples, you can see it was cut off approximately here, and then using other sheet stock, whatever, they modified that tank to be a big flanged connection. This, the competition would likely say, oh yeah, we have a 1-inch thick lid. We have a non-skid aluminum cover, but how long is this connection and whatever they've done here going to suit a below grade application in the facility? Sure, the contractor's going to say to save themselves $1,000 because of something in this scenario. And if you've received it and you've looked at it and you haven't paid attention to the detail, this is essentially what you're going to get. So you end up with a garbage can and some rocks in it to do the job of something that's holding corrosive material. And the video here playing shows this copper line within this mechanical room absolutely blackened with the corrosive vapors coming out of that neutralization tank because it can't seal properly because of how flimsy that lid is. So moving on here, can it hold the liquids and gases? Test it like the pipe. Put 5-pound pressure or a head test on it, 10 foot ahead. Not all neutralizers are created equal, and the fabrication practices and whatnot, materials selected, all have to be scrutinized by all of us involved. So gaskets, stainless steel, not zinc, empty sumps versus functional capacity. The stone itself, if it's a limestone system, you're not just using any aggregate that you would get at your garden center. You want to make sure that it's a high calcium content aggregate. Do you need a probe? Or does the client want to monitor that pH? Does it want to have bells and whistles and alarms? Again, venting, all of this has to be taken into consideration. Interceptors, just real quick, I'm going to jump into sediment interceptors. Why do you want them? I mentioned, again, the blockage of this dip tube. What is the blockage from typically? This. You have these are the three biggest guilty culprits. Broken glass. So you have broken test tubes and beakers and whatnot in the sink. People will do their best to remove the glasses, but you'll always have pieces left that end up down the drain. Top right-hand side, those are called Eppendorf pipette tips. I remember in my lab days, you transfer, anybody that's in a CSI fan, transfer liquid from one tube to another. You use those protective tubes so you don't cross-contaminate. And again, pH litmus paper strips. So they're in the beaker and they inadvertently get dumped down the drain. That's what we're trying to prevent from getting clogged in the system. And that's how you have to consider it as a system. So you have your interceptors, your neutralizers, your pH monitoring. Is it injection? Is it gravity? All of these things come into play because they're engineered design systems, not a magic box.
Another question, Owen, says HDPE burns hot quickly and produces large volumes of nasty black smoke. and are generally not allowed by building codes and the plumbing system. What's the alternative?
To HDPE?
Yes.
That's a great question. Again, it has to be suitable for the purpose. So high density polyethylene, similar to polypropylene, is a polyolefin. That's why you'll normally see high density polyethylene selected for the neutralization system. There is polypropylene available. If you're going to specify polypropylene pipe and fittings in your building and you get to a polypropylene tank, it's a polyolefin, and that's the reference in the building code in the national code is 2281. Alternatively, stainless, a stainless steel tank, fiberglass tank. Really, predominantly what you're going to see is high density polyethylene because of the cost. But again, polypropylene is available. It comes with typically a higher cost and longer lead time. But I have seen stainless steel tanks or lined concrete tanks. There are variations out there. There's Adam Brooks raised their
I
hand.
see raised hand. I don't know how to answer raised hands. Hi, Adam. Do you have a question? Adam Brooks.
Maybe Adam has.
It says accident. It said accident. Right, that was my accident.
Okay, so yeah, I always like to leave time for questions at the end. We have a couple minutes left, and I know I talked quickly through it. There's a lot of information, but I wanted to get to some takeaways, which is essentially the 2281. You have to conform to the CSA B1 and A1.3 pipes and fittings, the borosilicate glass. The Durire doesn't exist, so we're left with three options here. Don't let anybody try to come up from or come in from another area and say, "Oh, we use this quite successfully in other areas." And I'm not pointing fingers at any of our U.S. counterparts that are on this in the audience, but they're different countries, different regions have different code. What I was specifying specifically on the onset was the National Code of Canada. It says thou shalt conform to A, B, or C. CPVC is a product on the market in DWV applications. It does come with its list of features and benefits, but it's not a permissible product for corrosive waste here in Canada. I don't know if there's any other questions anybody had.
I don't see any questions. Anyone has any questions?
Yeah, and if I can interject or just fill in a little bit of time here, injection systems are gaining in popularity. They typically are smaller footprint, and they are easier to maintain. The facilities people tend to like maintaining them more than they do the limestone units. And more often than not, the limestone units, they never top up the neutralization stone like the limestone and whatnot. But anyways, seeing a more of a growth in injection systems and on projects over the last few years for sure.
What I'll do is in the last 2 to 3 minutes here, I'll do a quick demo and show where you can find the asset interceptors on our tool. If you can stop sharing, okay, you just did, there you go. All right, so this is our new dashboard, if you say, that we just rolled out recently. So now you can start a new project right from here. If you have, and also we've added ATS templates, which is our, you can say our own masters where you can go in and copy products depending on the projects you're working on. So if you go to ATS templates, for example, you'll be able to search. So if you're working on a school, if you do education, you will find educational masters that we have built, and you can copy your products from there. But I just wanted to show you here how you can add in those asset interceptors. So if we go to new spec, we'll do a test spec here. It's going to take you to the product category page. So we're looking for chemical waste and neutralization tanks. Now you can always pin it as a favorite, so that when you come back here to your product category page, it will always be on the top. So if you click on chemical waste, you will see your acid neutralizing tank. We've also added the select most popular option here. What it would go by what's been selected the most. But one thing that we can always do for you is size it and select the appropriate model for you. So if you contact us, if you contact me directly, if you're going to contact your account manager or a spec team, we can always make sure we select the right appropriate products for you and the right capacity as well. You can also select the options that Owen mentioned earlier in terms of what you're looking to add as well to your selection. And you can add product. And just like that, you've added your neutralizing tank. Complete. And now we can select all drawings, download, and you can select the download format you're looking for. One great addition that we've done also recently is that now you can pre-select all the download formats you're looking for. In the past used to be you download each format separately, but now you can download your submittal, your long spec, your schedules, for example, generate document, and the system will create all 3 documents for you at once, and you can download all files together as well. Just want to see if there's any questions while this is downloading. Questions, okay. 3, all right, there you go. So download all files. I'm not sure if I'm sharing all my screen. Can you see the download format or not? Owen, can you see the download format?
I could just see the 3 out of 3 files were successfully generated.
Okay, so let me stop share again. All right, there you go. So this is the PDF format for, this is your cut sheet for the acid neutralizing tank. We go back, we can get the long spec format as well. There you go. And lastly, you can find your Excel format for your schedule as well. See, there's a question. Thanks, Yesenia. And I think we're right on time here. Again, I just wanted to thank everyone who joined us today. Thank you for taking the time. I hope it was very informative. As I mentioned earlier, we will be sending out the certificate of attendance by the end of the week to everyone that attended today. If you have any questions, please reach out to me or your account manager or to Owen directly. We'll be more than happy to assist you.
Yes, thank you very much, everybody, for your time. I appreciate it. And again, thank you, Mo and ATS for the opportunity.
Thanks, everyone. Thanks, everybody.
Take care, everybody.
Enjoy the rest of your day.
You too, Mo.